right, this is section 8, topic 2. And it's called Expressions with Radicals and Rational Exponents, part 2. So the one that we did, the first section that we did, that was the same thing, but it was a part 1. Okay. And the target how can you use the properties of exponents to rewrite a radical expression as an expression with a rational exponent. Can somebody get that, please? Thank you. And vice versa. And remember to make space for your questions, concepts area over in the margin. Don't forget to put your name on it as well. All right, so in this section we're just going to do a bunch of examples of simplifying radicals. And then we'll probably also be able to move on to topic 3 today as well, okay? All right, so the first thing we're going to do is rewrite using radicals. Example 1. We have, open parentheses, 6d quantity raised to the 1/4 power. So we did not have any problems in our last lesson that had rational exponents. Remember, rational is fraction, okay? When you do have rational exponents, you can convert that into a radical if you know how. So I'm going to teach you how today. And sometimes it's easier. Sometimes it's easier to simplify your problem with an exponent. Sometimes it's easier to simplify it as a radical. It just kind of depends. So if I told you to simplify this, 6d raised to the 1/4 power, you might be thinking, well, what does it mean raised to the 1/4 power? So what you can do is convert it to a radical. So the base inside the parentheses, that would be your radicand. Okay, that's what's under the radical. Whatever the denominator of the fraction is, that's your index or your root. Okay? Whatever the numerator is the exponent of the radicand. So you could write it like this. So 6d raised to the 1st power, and obviously if your exponent is a 1, you don't need to write that. But say it was a 2 or a 3 or a 4, that would be important. Or another way you could see it written was the fourth root of 6d, and then you could see parentheses around the whole thing. Again, exponents 1, it doesn't make a difference. So the 4, or the denominator, is your index. And then the numerator is the exponent of the radical. That's tiny. Exponent, index. Now, if we could simplify that further, then we would. 6d raised to the first power is just 6d. Does the number 6 have a perfect fourth in it? No, because 6 breaks down to 3 times 2. So we can't break that down any further. And d, does it have a perfect fourth? No. So that's all we can do, okay? But if we could simplify it, a lot of times a radical will help us do that. All right, so let's just do a few more examples so you know how to convert from rational exponents to radicals. Example 2. If we had, open parentheses, 5a squared, quantity raised to the 2/3 power. And we want to convert that to a radical. What would my index be? 3. So that would be the cubed root of 5a squared, quantity raised to the what? To the second power. So you can either do the whole thing in parentheses. I like to just do the inside, but either way it doesn't matter. So me personally, it makes more sense to write it like this: 5a squared, quantity squared. This looks confusing to me when it's the whole thing in parentheses. This doesn't, but it means the same thing. Okay, so whatever makes most sense to you. So let's see if we can simplify that a little bit. Because we have exponents with exponents, we know that's a power to a power rule, right? So that would be the cubed root of, what is 5's exponent before you raise it to the second power? 1. So we know when we have a power to a power, we keep the base and do what to the exponents? Multiply. Power to a power. Keep the base, multiply the exponents. So since 5's exponent is 1, 1 times 2 is 2. And a squared, quantity raised to the second power, would be a to the 4th. All right, well, we know that 5 squared is 25. A to the 4th. Let's see if we can simplify that any further. 25, is it a perfect cube, or does it have any perfect cube factors? Nope, because we know 25 breaks down to 5 times 5. That's the prime factors, and you only have 2 of them. We need 3, right? What about a to the 4th? Could we break that down a little bit? A cubed times a, exactly. And then, so that way, we could take the cubed root of a cubed, which is what? A. So we would have an a outside of the radical, that'd be the coefficient, time, anything else in there we can take the cubed root of? No. So times the cubed root of 25, and this a will stay under the radical of the radicand as well. So that's all we can do. What if anybody have a question? Okay. What if I had 3 raised to the 2/5 power? All right, let's rewrite that as a radical and see if we could simplify it. What would the index be? 5. So that would be the 5th root of what? 3 squared. Or we know that means the 5th root of 9. Do you think 9's a perfect fifth? Does it have any perfect fifth factors? No, because its prime factors are 3 times 3. It's a perfect square, but it doesn't have, I don't have 5 of anything, right? So that's all I can do. Does everybody understand how to rewrite with a rational to a radical. Okay. All right, so now we're going to go in the opposite direction. We're going to rewrite using rational exponents. Rewrite using rational exponents. So, example 4. I have the cubed root of, open parentheses, x plus 2 quantity raised to the 4th power. Now I could actually simplify that because I have four roots, x plus 2, or 4 factors of x plus 2. I only need 3. But that's not what it asked me to do. It just said rewrite using a rational exponent. Okay? So I'm going to go from radical form to a base with a rational exponent. So what's my base going to be? X plus 2. And that's got to be in parentheses because the whole thing is going to be raised to the rational exponent. And what would the exponent be? 4/3. Because the index is the denominator, the exponent is the numerator. Coolio? All right. Example 5. I have the 6th root of y times the cubed root of y times the 5th root of y squared. Now, as these are right now, could I multiply these radicands together? Why not? They don't have the same index, right? So if they all had if they were all the cubed root, or they were all the 5th root, or they were all the 6th root, I could multiply the radicands together. But none of them have the same root, so I can't do that. So if you were supposed to simplify, you would want to try, okay, well, let me rewrite this as a base with a rational exponent, okay? So what would the 6th root of y be? Y to the 1/6 times what? Y to the 1/3 times y to the 2/5. Good. Now, can I multiply when I have like bases? Yeah, I could totally do that, right? The rule says when you're multiplying and you have a basis with index, if it's the like base, we keep the base and do what? Add the exponents. And it didn't really ask us to simplify, but we might as well go ahead and do that. We know how to add fractions, right? Yeah. So I'm going to do that over here on the side. Before you can add fractions, what do you need to have? Common denominator. Remember when we were finding the least common denominators before our last test? Well, this is kind of the same thing. Least common denominator. What's the smallest number that 6, 3, and 5 will all divide into evenly? 30. Now, sometimes students find a common denominator. It might not be the least common denominator. That's okay. You'll just have more reducing in the end. Okay? So, remember how to add fractions. We're wanting to make equivalent fractions all with the same denominator. So, 6 times what gave me 30? 5. So, 1 times 5 is, doesn't 5/30 reduce to 1/6? Okay. 3 times what is 30? 10. So 1 times 10 is 10. 10/30 reduces to 1/3, right? They're equivalent. 5 times what is 30? 6. So 2 times 6 is 12/30 reduces to 2/5. They're equivalent. So once we have common denominators, we can add. You don't add the denominator. You just leave that the same. Add the numerators. 5 plus 10 plus 12 gives me 27/30. Which I can reduce exactly to what? 9/10. So over here, that is y to the 9/10. Or if they wanted us to convert it back to a radical, it would be the what? The what root? 10th root of y to the 9th. And could I simplify that? I would need 10 y's, right? I only have 9, so I couldn't. But these are equivalent. Everybody good? Everybody good? Okay, so I'm going to move on to the next page. I'm out of room. Anybody still writing on this page? Okay. Example 6. We have the cubed root, and this is going to be a fraction under this radical, of 8x to the 7th divided by, open parentheses, 27 y to the 5th quantity, and that's just in the denominator, raised to the negative 1. And I'm going to rewrite this using rational exponents. But before I do that, I probably would get rid of that negative exponent. And do we remember how to do that? You have a negative exponent. What do you do to get rid of it? Move it up, right? If it's in the denominator, we'll move it to the numerator. If it's in the numerator, we'll move it to the denominator. So that's going to be the cubed root of 8x to the 7th times 27 y to the 5th. And do I even need to put to the first power? No. So at this point, if I wanted to, I could do 8 times 27. I could do that. But I'm not going to. I'm going to wait. Okay? So I have different terms in here. I'm going to raise this whole thing to the 1/3 power technically. So I could put it in one big parentheses and do it that way, but to me it's easier just to take each individual piece by itself, okay? So that would be 8 raised to the what? 1/3 power times x raised to the 7/3 times 27 raised to the 1/3 times y raised to the 5/3. Okay, let's see if we can simplify some of this. Y'all know that 8 raised to the 1/3 power is the same thing as the cubed root of 8, right? So what is 8 raised to the 1/3 power? 2 times, I'm going to leave that x to the 7/3 times 27 raised to the 1/3 power, that's the same thing as the cubed root of 27, which is 3 times y to the 5/3. Okay, can I multiply the 2 and the 3 together? Yeah. So that's going to be 6x to the 7/3, y to the 5/3. So since technically the directions just said rewrite using rational exponents, I'm not going to turn those back into radicals, the variables, to see if I can simplify them.
So the 1/3 fraction meant like to cube root it?
Yes, because think about it. If we converted that back to a radical, that would mean the cubed root of 8 to the 1st, right?
Yeah.
Which is basically the cubed root of 8. So cubed root of 8 is 2. Yes, so when you see something, or if you see something raised to the 1/2 power, what are you doing to it?
Cube root, or not cube root, square root.
Square root, right? Something raised to the 1/4 power, 4th root. So if you have a 1 in the denominator, you can just simplify that in your head, probably.
But you couldn't do that if it was like 2/3.
Right,
Because
so then you'd have to,
it's not a 1 in the...
right, you'd have to square it and then take the cube root of whatever you get. All right? Okay, how about this example? Example 7. We have, okay, this one's kind of crazy. We're going to take the square root of a square root. We're taking the square root of the cubed root of y plus 1 quantity raised to the 4th power. Okay, so let's rewrite the innermost radical first with a rational exponent. Okay, so that would be the square root of, open parentheses, y plus 1 raised to the what? Just look at the innermost radical, 4/3. All right, so now we're going to take this and raise it to the 1/2 power. Okay, because the square root, 1/2 power. So that's y plus 1 raised to the 4/3, quantity raised to the 1/2 power. So the 4/3 exponent only goes with the y plus 1. Then the square root, its exponent was just 1. Nothing was shown, so its exponent was 1. That's kind of confusing because you see this fraction here, okay? So now we have a power to a power. Our base has a power, which has a power. So we know when that happens, we keep the base and do what to the exponents? Multiply. 4/3 times 1/2. So that's easy. Remember, when you multiply fractions, you multiply numerator times numerator, denominator times denominator. So that would be 4/6, which reduces to 2/3. So that looked kind of crazy at the beginning, but really not a big deal. As long as you just know your rules. All right, now I'm going to give you some to try. I want you to rewrite using radicals. And the problem is 10y quantity raised to the 2/3 power. So rewrite it as a radical, and if you can simplify at all, simplify as much as you can. Anybody have an answer? Yes, ma'am. The cubed root of what? 100y squared. Did anybody else get that? Yep, that's what I got as well. Okay, so if we convert this to a radical, what's my index? 3. So the cubed root of 10y quantity squared. So we know that means the cubed root of 10 is being squared and y is being squared, right? Well, what's 10 squared? 100. And 100. Let's just go with this. 100 y squared. Is 100 a perfect cube?
No.
No. Does it have perfect cube factors?
I
Hmm?
tried looking at it.
It doesn't, right? So if I break that down, my prime factors will be 2 times
Didn't someone just not?
5 times 2 times 5.
Was there no one there?
No.
They must
There
have put
was,
the wrong
but
five
yeah, I'm thinking that's what happened. So there's nothing else I can do. And y squared, there's only 2 of them. I need 3 to simplify it, right? So, good to go. All right, try this one out. So now I'm going to give you a radical, and I want you to just write it with a rational exponent. And the problem is the 4th root of the square root of x minus 1 quantity raised to the 5th power. So you're just rewriting it. Do the innermost radical first, and then the outermost, and just rewrite x minus 1 with a rational exponent. Anybody got the answer?
Is it x minus 1 to the 5/8?
That's what I got. X minus 1 raised to the 5/8. Did y'all get that?
Yeah.
All right, good. So innermost radical would be x minus 1 raised to the what?
5 over.
5 halves, right? So that's the 4th root of that. And so then we would take x minus 1 quantity raised to the 5 halves quantity raised to the what? 1/4. So rule says when you have power to a power, keep the base, multiply the exponents. So that's 5 halves times 1/4. So we get x minus 1 raised to the what? 5/8. And can I reduce that? No. No. Okay. So on my paper, I have enough room for the summary at the bottom. This is the end of topic 2. And I'm going to stop this video. We're going to go ahead and do topic 3, but I want to put it on a different video. Okay, so I will pause this and just restart another one. Everybody okay with this? Anybody have questions? Woo. Okay.